Hello Acute Angels, this is Teacher Anna and welcome to another Arithmetic episode. In this video, we are going to talk about Arithmetic Sequence, Arithmetic Means, and Arithmetic Series. Well, at the end of this lesson, you are expected to illustrate an arithmetic sequence, determines arithmetic means, and term of an arithmetic sequence and sum of the terms of a given arithmetic sequence. We begin with the arithmetic sequence. What do we mean by arithmetic sequence? Well, an arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called the common difference. In short, for us to get the next term, we just add the same number. For instance, the sequence 1, 4, 7, and 10 is an example of an arithmetic sequence because we just add 3 to the preceding terms to get the next. And the number that we add now is what we call the common difference. We get the common difference by subtracting two consecutive numbers in the arithmetic sequence. For example, 4 minus 1 is 3, 7 minus 4 is 3, and 10 minus 7 is 3. Since we just add the same value in an arithmetic sequence, therefore, the general term of an arithmetic sequence is a sub n is equal to a sub 1 plus the quantity n minus 1 multiplied to d, wherein a sub n is the nth term, a sub 1 is the first term, and d is the common difference. Let us have an example. What is the 10th term of the arithmetic sequence 5, 12, 19, 26, and so on and so forth? Of course, in the first step, we determine the given. A sub 1 or the first term is given, which is 5, and the value of d or the common difference is 7. We get 7 by subtracting two consecutive terms in the sequence. For instance, 26 minus 19, which is 7. And for us to get the value of the 10th term, we use the general formula of an arithmetic sequence, which is a sub n is equal to a sub 1 plus the quantity n minus 1 multiplied to d. Then we substitute the given to the formula. We now have a sub 10 is equal to 5 plus the value of n, which is 10 minus 1 multiplied to the value of d, which is 7. 10 minus 1 is equal to 9. Then we have 9 multiplied to 7, which is equal to 63. We now have 5 plus 63, which is equal to 68. Therefore, the 10th term of the arithmetic sequence 5, 12, 19, 26 is 68. If a sub 1 and d are known, it is easy to find any term in an arithmetic sequence by using the formula a sub n is equal to a sub 1 plus the quantity n minus 1 multiplied to d. But what if one of it is unknown? Consider example number 2. Find the indicated term using the following information. The value of a sub 6 is equal to 28 and d is equal to 5, and we need to find the value of a sub 15. Well, in order for us to solve this one, we are going to work with the same formula. So we use a sub n is equal to a sub 1 plus the quantity n minus 1 multiplied to d. But in this case, we need to solve for the value of a sub 1 first. How do we do that? We solve a sub 1 in terms of a sub 6 and d. So we have a sub n, which is equal to a sub 6, and the value of a sub 1 is unknown, so we write a sub 1 plus the value of n, which in this case is 6, minus 1 multiplied to the value of d, which is 5. The value of a sub 6 is given, which is 28, equals a sub 1 plus 6 minus 1, which is 5, multiplied to the value of d, which is 5. 5 multiplied to 5 is equal to 25. Then we have 28, which is equal to a sub 1 plus 25. For us to get the value of a sub 1, we transpose 25 to the other side. So we have 28 minus 25. 28 minus 25 is equal to 3. Therefore, the first term is 3. Now that we know the value of a sub 1, we can now solve for the value of a sub 15 using the same formula. So we have a sub 15 is equal to 3 as the value of a sub 1 plus 15, the value of n, minus 1 multiplied to the value of d, which is 5. So we have 15 minus 1, which is 14, and 14 multiplied to 5, which is equal to 70. We now have 3 plus 70. 3 plus 70 is equal to 73. Therefore, the value of a sub 15 is equal to 73. Next, we proceed to example number 3. What if the given is like this? We need to find the indicated term using the following information. A sub 1 is equal to 5, a sub 7 is equal to 17, and a sub 20 is the unknown. Of course, for us to solve it, we will use the same formula, which is the a sub n is equal to a sub 1 plus the quantity n minus 1 multiplied to d. But we need to solve for the value of d first in terms of a sub 1 and a sub 7. So we have the value of a sub n, which is a sub 7, equals the value of a sub 1, which is 5, plus the value of n, which is 7, minus 1 multiplied to d. A sub 7 is given, which is 17, equals 5, plus 7 minus 1 is 6 multiplied to d. Then we have 17 equals 5 plus 6d. For us to get the value of d, we isolate d and we transpose 5 to the other side. We now have 17 minus 5 equals 6d. 17 minus 5 is equal to 12 equals 6d. And for us to get the value of d, we divide both sides with 6. So we have 12 divided 6, which is equal to 2, and 6d divided by 6 is equal to d. Therefore, the value of the common difference, or d, is equal to 2. Now, knowing the value of the common difference, we can now solve for the value of a sub 20. Using the same formula, we have a sub 20 equals 5, the value of the first term, plus n, which is 20 minus 1 multiplied to 2, the value of the common difference. 20 minus 1 is equal to 19, and 19 multiplied to 2 is equal to 38. We now have 5 plus 38, which is equal to 43. Therefore, the value of a sub 20 is equal to 43. Well, aside from knowing the nth term of a sequence using the formula a sub n is equal to a sub 1 plus the quantity n minus 1 multiplied to d, we can also identify the term of a given number in a sequence. For example, in the sequence 5, 7, 9, 11, and so on and so forth, what term is 45? Of course, for the first step, we determine the given. The value of a sub 1 is 5, which is the first term. D is the common difference, which is equal to 2. We obtain 2 by subtracting the 2 consecutive terms in the given sequence. For instance, 7 minus 5, which is 2. And the value of a sub n is equal to 45. And the value of n is unknown. Of course, our formula is a sub n is equal to a sub 1 plus the quantity n minus 1 multiplied to d. We now substitute the given to the formula. We now have 45 is equal to a sub 1, which is 5, plus n minus 1 multiplied to d, which is 2. Then we distribute 2 to the quantity n minus 1. So we have 2 multiplied to n, which is equal to 2n, and 2 multiplied to negative 1, which is negative 2. And we now have 5 minus 2, which is equal to 3. Then for us to get the value of n, we will transpose 3. So we have 45 minus 3 equals 2n. 45 minus 3 is equal to 42. So we have 42 is equal to 2n. And for us to get the value of n, we divide both sides with 2. So we have 42 divided by 2, which is equal to 21. And 2n divided by 2 is equal to n. Therefore, the value of n is 21. In the sequence 5, 7, 9, 11, 45 is the 21st term. And that's all you need to know about arithmetic sequence. We now proceed to arithmetic means. What do we mean by arithmetic means? Well, when we say arithmetic means, they are the terms between any two non-consecutive terms of an arithmetic sequence. For instance, when three terms form an arithmetic sequence, the middle term is called the arithmetic mean between the other two. For example, if we have 2, 4, and 6, the middle term, which is 4, is called the arithmetic mean between 2 and 6. And if we have 5 terms like this one, we have 2, 4, 6, 8, and 10. The arithmetic means between 2 and 10 are 4, 6, and 8. So, if we are tasked to insert arithmetic means between two numbers, we just need to identify the value of the common difference for us to get them. Let us have an example. In example number 1, we need to insert 3 arithmetic means between 3 and 23. If we are going to represent it, 3 will serve as the a sub 1 or the first term, while 23 will serve as the fifth term or the a sub 5. And we are tasked to identify the value of a sub 2, a sub 3, and a sub 4. For us to get it, we need to identify the value of the common difference. So we use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 multiplied to d. Substituting the value of a sub 1 and a sub 5 in the formula, we have a sub 5 is equal to 3 as the value of a sub 1 plus 5 as value of n minus 1 multiplied to d. A sub 5 is given, which is 23 equals 3. Then 5 minus 1 is equal to 4 multiplied to d. For us to get the value of d, we isolate d on the other side, so we transpose 3. So we have 23 minus 3, which is equal to 20. Our equation now is equal to 20 equals 4d. Then we divide 4 on both sides. So we have 20 divided by 4, which is 5. And 4d divided by 4 is equal to d. Therefore, the common difference is 5. After identifying the common difference, we now add them to the preceding terms. The preceding terms is 3, which is the first term. So we have 3 plus 5 equals 8. 8 then is the a sub 2 or the second term. For us to get the third term, we add 5 to 8. So we have 8 plus 5, which is equal to 13, which is the a sub 3. And we then add 5 to 13. 13 plus 5 is equal to 18. And that is the value of a sub 4. The arithmetic sequence is 3, 8, 13, 18, 23. Therefore, the three arithmetic means between 3 and 23 are 8, 13, and 18. For our next example, find the arithmetic mean between 9 and 49. When we say arithmetic mean, we are just looking for one term in the middle. Wherein, if we represent the given, 9 is the a sub 1 and 49 is the a sub 3. And a sub 2 is the middle term. Since a sub 2 is in between two numbers, basically, we are just looking for the average. So in this example, we don't need to identify the value of the common difference. We just get the average of the two numbers and that will be the value of a sub 2. In identifying the average, we just add a sub 1 and a sub 3, then we divide it to 2. We have 9 as the value of a sub 1 plus 49, the value of a sub 3, divided by 2. 9 plus 49 is equal to 58. And 58 divided by 2 is equal to 29. The value of a sub 2 is 29. The arithmetic sequence is 9, 29, 49. Therefore, the arithmetic mean between 9 and 49 is 29. And that's all you need to know about arithmetic means. We are now down to the last part of our lesson, which is the arithmetic series. What do we mean by arithmetic series? Well, an arithmetic series is the sum of the terms of an arithmetic sequence. Basically, we just add the terms in an arithmetic sequence. For instance, if the arithmetic sequence is 1, 3, 5, and 7, we just add them all together. Adding them, we have 16. Therefore, the arithmetic series of 1, 3, 5, and 7 is 16. Basically, in arithmetic series, we just add the first few terms of an arithmetic sequence. And the formula for the sum of the first n terms of an arithmetic sequence is s sub n is equal to n over 2 multiplied to the quantity a sub 1 plus a sub n, wherein s sub n is the sum, a sub 1 is the first term, and a sub n is the nth term. If the nth term is unknown, we can just use this formula. S sub n is equal to n over 2 multiplied to the quantity 2 multiplied to a sub 1 plus the quantity n minus 1 multiplied to d. It is by substituting the formula for the general term in the arithmetic sequence. In here, s sub n is the sum, a sub 1 is the first term, and d is the common difference. Let us have an example. For our example number 1, find the sum of the first 10 terms of the arithmetic sequence 5, 9, 13, 17, and so on and so forth. The first step is to identify the given. We have a sub 1, which is 5, and the common difference is 4. And the unknown is s sub 10. Since a sub n is unknown, we use the second formula, which is s sub n is equal to n over 2 multiplied to the quantity 2 multiplied to a sub 1 plus the quantity n minus 1 multiplied to d. Then substituting the given, we have s sub 10 is equal to n, which is 10 over 2 multiplied to 2 multiplied to a sub 1, which is 5, plus the value of n is 10 minus 1 multiplied to 4. 10 divided 2 is equal to 5, and 2 multiplied to 5 is equal to 10. Then 10 minus 1 is equal to 9. Then we write 4. 9 multiplied to 4 is equal to 36. So we have 10 plus 36, which is equal to 46. Then we multiply 5 and 46, and the result is 230. Therefore, the sum of the first 10 terms of the arithmetic sequence 5, 9, 13, 17, and so on and so forth is 230. And for our last example, find the sum of the arithmetic sequence 1, 6, 11, 16, 21, 26, 31, 36, and 41. Well, we can just add them all together, but since we have a formula, we can use it. We identify first the given. A sub 1 is given, which is 1. And the a sub n, which is the last term, is equal to 41. And the value of n, which is the number of terms in the given sequence, we have 9. And the unknown is s sub 9. So we use the first formula since a sub 1 and a sub n is given. So we substitute the given to the formula. We have 9 over 2 multiplied to 1, which is the value of a sub 1, plus 41, which is the value of a sub n. 1 plus 41 is equal to 42. And 42 multiplied to 9 is equal to 378. We now have 378 divided by 2, which is equal to 189. Therefore, the value of s sub 9 is equal to 189. And that's all you need to know about arithmetic series. I hope you are now ready to answer your learning activity sheets related to it. Again, when we say arithmetic sequence, it is a sequence where every term after the first is obtained by adding a constant called the common difference. And when we say arithmetic means, these are the terms between two non-consecutive terms in a arithmetic sequence. And when we say arithmetic series, it is the sum of the first few terms of an arithmetic sequence. Once again, I am Teacher Anna, and see you on another Matinic episode. Thank you and keep safe.